Hey, what's up, guys? Chung here again. And so let's take a look at last week's or this week's weekly contest. One of the problem, 1552 magnetic force between two balls. Um, in the universe Earth C dash 137 blah blah blah. Okay, and basically we have a list of numbers. Okay, and we have a list of numbers of positions of the bucket, and we have a target, right? Target is M. So the M means we need to put like we need to put this M balls into this baskets. But we have a rule that, right? So we want to put those balls into the basket so that the minimum magnetic force between any two balls is maximum. Okay. So it's also like, see, it's a minimum thing. The minimum graphic force between any two balls is maximum. Okay. And they ask us to find the that the minimum, like actually the maximum force between any two balls. Okay. After we wisely choosing the bucket to put in our balls, and the the magnetic force between two balls is as this. Is the it's absolute difference between the x and the y. So, for example, this one, right? This one is like 1, 2, 3, 4, 7, and we have M3 here. So the first time we put into the 1 here, and then the 7, and then the 3. Okay, and this one 1 and just a huge number. Okay, that's the difference here. Mm, Okay, so how can we how can we solve this problem, right? I mean, so the idea here is that, I mean, we have to use binary search, but how to use binary search? This is like a tricky part, right? I mean, there's some like a few other similar problems in LeetCode, like the cocoa eating bananas, or like the ship like uh, transporting a few peoples, something like that, you know. And as it in this problem here, so what we need to do is that basically for the binary search, what we do, we directly search the answer here. Okay, and since we're trying to search the maximum number, right? Because we're trying to search the maximum number, and and we're trying to search the 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 answer directly, and so that we need to have like a range here, right? So okay, I'll try to explain this one. So it's a little bit confusing. I mean, the lower bound. So what's the lower bound? The lower bound is 1, okay, right? Because the smallest force we could possibly have is like those two buckets are next to each other, and yeah. So how about the upper bound, right? So the upper bound is what? Is the, okay, so first, before doing that, we have to sort. We have to sort our positions, right? We have to sort it from the smallest to the biggest, so we can have like, we can do our greedy search here, right? Or binary search. For the binary search, you guys know it has to be a sorted, right? And for each of the binary search, we're gonna need like a helper functions to help us track, right? You know what? Actually, I'm gonna finish the main code, and then I will try out. We'll talk about the the helper function here. So, and the lower bound is 1, and upper bound is this, right? After sorting the position, -1. Okay, so that's the upper bound, right? And then while left is smaller than right, okay? So middle, what's the middle here? We have a middle here, and I'm gonna write the standard template here, and we will change this one later on, and I'll explain why. Okay, okay, and if right, if helper right, if helper function it's true, right? Let's say if helper is true, then we do what? We do a left equals to middle, right? And then else right equals to middle minus one. Oh, and here we simply return left. Okay, I mean many of you must have know this kind of like binary search template, but a few things need to be noticed here. Okay, so first, right? So first we're looking for the maximum value. Okay, so looking for the max values, okay, you know what? Let me try to finish this one. So the helper functions, in our case, so what's gonna be our conditions here, right? So since this middle is our current like the current like the maximum distance between all the bars, right? So what are we checking against with? Basically, we're checking against with m here. What does it mean? It means that with the current distance as the middle value here, how many bars we can fit into other positions. Okay, so that's when we need like a count. I'm gonna have like a count method here, right? This one is gonna be the distance. Okay, so what does this mean? It means that with this distance, like how many bars we can with this like as a minimum distance, right? With a minimum distance, how many bars we can fit into into all the baskets. Okay, and so let's assuming we already have this count method implemented somehow. Okay, so something like this, right? So basically, if the count is greater than m, what does this mean, right? It means that with this like the middle as the as the minimum distance, we can fill more balls than the answer, which means the distance is too small. Okay, right? So that we have to move move our middle, we have to cut our left part and we have to move to the right part, right? Same thing for this, right? Same thing for this else if middle else if the count is smaller than m, which means our middle this distance is too big. It's big enough that we cannot even fill our required m balls into the into all the baskets. Okay. Okay, so that's that. And then how about this, right? So these two are easy to understand. Okay. Then actually the question comes down to what if this middle is equal to m? What's gonna happen here, right? Mm, okay. I mean, as you guys can see, so let's say the count equals to middle is equal to m. Okay, so what does this mean? It means that with this middle as a distance, we can, I mean, we can put we can put exactly m balls into the basket. But is that but does it mean the middle is our answer? Not necessarily, right? Because there could be a lot of middle that could give us like the m count here, right? And we're looking for what? We're looking for the maximum one, right? Then what does it mean? So to find the maximum one, so that means that this middle one, okay, so it could be our result. It could be our result, but it could be we could have like a bigger value that can also give us this m. So in that case, what do? We do this, right? We do left equals to middle. Since we're going to move towards the right, we are looking for the bigger value of left. We're trying to find if there's a bigger value of left, of the middle that can satisfy this this number here. And in the end, okay, so in the end, when the left equals to right, we simply return left. That will be our answer. Actually, as you guys can see, and we can like combine these two together into one here, right? So that, I mean, in this case, we have to do this, okay? So basically, it means that as long as if the count is equal or greater than m, then we know, okay, we have to go to the right side. You know what? Actually, let me try this to see if this will work. Okay. And there's like a small trick here. I mean, anytime when you guys see whenever we have a left equals to meet the middle here, you know, this is our a regular way to get in m here. But with the left equals to middle here, we have to do a right minus left plus one here. Why is that? Let's say we have a three. Mm, let's say we have the left is 3 and the right is 4. Okay, so for with these two, right? If we're not doing the plus 1 here, so what are we getting here? We're getting 3 here, right? Yeah. So the middle is 3, right? The middle is 3, and so whenever this happens, right, and the left will stay as 3. Basically, it will end up in an infinite loop. So that's why whenever this happens, instead of getting 3 for the middle, we want to get 4, so that the left this condition can be terminated. That's why we need to add like a plus 1 here. Okay, so now let's implement this count here. Since we know the limitation of the count here, so each of the minimum, right? Basically the minimum distance between each ball is d here. So so at the beginning is 1, and the previously position is position 0. Okay, right? And then we just loop through everything for I in range uh 1 to the length of position. Okay, I know what, actually I'm gonna have an n here. Position 1 to n. Since we're starting from the second one, right? Because that's when we can compare the distance. So basically what we're trying to do here is if the position I, right, uh, minus the previously position, okay, is equal or greater than the distance, okay, then we increase the answer by 1, and then we update this pre-position with the current one, okay, And in the end, we simply return the answer here. And as you guys can see here, so here is like a greedy approach here, right? But basically, we try to fill in as many balls as early as possible. Since this like position is already sorted, that's why we can fill in the balls as early as possible. Basically, every time when we see a ball, we see a position that can be fit in, can that we can put into the ball where the distance between the current position and the previous position is greater than d, and then we fill in the ball. We do it until we cannot do it. Okay, and yeah, so let's try to run this code here. Invalid else. Oh, I think yeah, else if yeah. Cannot assign to literal. What? Huh? Like this one? Oh, okay. So this test case passed. Let's try to submit it. Oh, oh, sorry. I think I made a mistake here. So here, let me try this. Yeah, let me try this. If this will work. Hmm. Yeah, this one doesn't work. I mean, I try to do this, so I mean, greater than that. Yeah, I think maybe this is the the problem here. I think we have to combine these two here. Basically, I mean, else. Yeah. Uh, Submit one more time. Oops. Else. Okay. So we don't need the else here. Yeah. Hmm. Okay, so so this one passed. All right. I mean, I I admit this one is like a tricky problem. I mean, just let's try to recap, do a quick recap for this problem. I mean, I think some of you, even for me, I mean, you guys must have some kind of feeling that, I mean, this problem should be solved by the binary search. But the question is how? Okay. Um, I think a few things you guys need to remember, even both for you guys and for myself, basically. And the first one is to use a binary search is essentially searching the result it directly. That's the first thing you guys need to keep in mind. Whenever you decide to use a binary search, you search the answer itself. So in this case, we search that this like the fault the magnetic force, okay, and and then okay, when after deciding, okay, we have this the search value here, we need to create like a helper function to help us to either go to the left side or go to the right side. Okay, and so and when it comes to this problem, the conditions we need to use is with that with the current distance, how many balls we can fit into the into all the sorted baskets. And to fit in the balls, we use the greedy way of doing it. Basically, we try to fill in the the balls, I mean, as early as possible until we cannot fit in that. Things like this, because let's say we have like uh, we have the 1, 2, 3, 4, and 7. And when we try to fill in, let's say when we try to fill in three balls with a distance, with distance 5, with distance 5 here. So distance is 5. Now we have 1 here, and then the second one is 2. 2 we cannot. 2 we cannot fill in because the distance is 1. And then we just keep looking, right? So as you guys can see, we only update the previously position whenever we see a valid position for us to fit in. Then we update the previous position. Otherwise, we keep going forward, right? So in this case, it's 1, 3, 4. Up until 4, the distance is 3. It's still 3, which means we have to keep going until we find a 7 here, right? So in this case, if we distance is 5, the answer here will be 2 here. Okay. And let's take a look. How about 2 here? Let's say the D is equal to 2, right? So 2 is like we can fill in 1, 1 is here. So the 2, we can fill in 3 here. So this is the first one to fill in because, and then the second one is 4. And then starting from here, we cannot use 4, but we can use 7. So with distance 3, we also have we also get like a 3 balls. But that's why, but for getting the 3 balls, we just need to keep looking forward until the left it has meet the right. Then we know we have found the maximum value. And because for this problem, we're looking for the maximum distance that can satisfy this arm here. And to do that, we have to use this template, right? Because whenever this happens, I mean, the left could be our result, but it could be not. It also could not be the result. That's why we need to keep this middle value here. Okay. And then, yeah, and whenever we have left equals to middle, we have to do this. We have to do a right left minus left plus 1 to make sure it will not end up in an infinite loop. Okay. Uh, cool. I think other than that, it's just mm, binary search. There are some like similar problems in LeetCode. Maybe I can list those similar questions in the LeetCode if you guys would like me to do it. But if you guys want to know those questions, leave me a comment and I can maybe summarize those problems and updates into the description of this video. And yeah, this is like a good a good way of refresh your memories, or like to how can we utilize the binary search template to solve this problem. And yeah, thank you so much for watching the videos and stay tuned. See you guys soon. Bye bye.